Greetings EGR 180 students, this is Unit 9, Advanced Part Creation for the CSWA. By the time you've completed this chapter, you'll be able to specify document properties, interpret engineering technology, build an advanced part from a detailed dimension illustration using the following tools: 2 and 3D sketch tools, extruded boss base and cut, fillet, mirror, revolve boss base, linear and circular pattern, chamfer, and revolve cut. Locate the center of mass relative to a part origin, create a coordinate system location, and locate the center of mass relative to a created coordinate system. There are 3 questions in the advanced part modification category. One question is a multiple choice single answer format. The other 2 are modifications to your advanced part model and are fill in the blank questions. Each question is worth 15 points for a total of 45 points. That's roughly 18% of the points possible. The advanced model that you will build has 6 or more features, and questions are either overall mass, volume, or center of mass. All you're going to get is a 2D SolidWorks drawing of the part. There will be no step-by-step. Often the only way to model a part is to use the geometric relations provided in the drawing. These drawings typically use variable A, B, and C, etc., and then has you change these later on during the modification stages. You really want to set up global variables for these. Odds are you'll need to reuse or to use reference geometry as well. Here's a sample drawing of an advanced part. By now, this shouldn't be too scary. If I were modeling this, I'd start with the cylinder in the middle. How would you model it? Here's another typical part showing the modification progression. Note that the savvy SolidWorks modeler has set up global variables. This way you can change dimensions by simply updating the global variables. This is a foolproof way to make sure you don't miss a dimension change with something that goes from like a divided by 3 to a divided by 4. It's really easy to miss this in the heat of the CSWA, but you won't miss it if you use global variables. Here's an advanced part from a prior CSWA exam I took. Note the default and configure A variations. This and the next slide are what came with the question. Looks like fun, huh? Again, I'd start this with a simple disk for the base and move on from there. As I mentioned earlier, this part of the CSWA will ask questions regarding overall mass, volume, and the location of the center of mass. One more time, please remember to set your material. Your mass value will be incorrect if you don't, even if your geometry is spot on. You should be very used to accessing mass properties by this stage in your studies. Also, don't forget you can change units, decimal places, etc. once you're in the mass properties box by clicking on options. Adding a new coordinate system can really save you during the CSWA exam if you inadvertently model a part with the origin incorrectly placed. Access this from under the Insert drop-down menu under Reference Geometry toolbar. Select the coordinate system and simply pick the new origin and 2 edges to orient the coordinate system the way you want it. Your new coordinate system will show up on your drawing as soon as you click OK. Once you've added a new coordinate system and you select Mass Properties to view the new center of mass, you must first select the new coordinate system via the Report Coordinate Values Relative to drop-down. There's a close-up of this on the next slide. If you don't select the new coordinate system, it'll use your default origin when it displays the center of mass. I've seen students during the CSWA exam correctly insert a new coordinate system and then get the COM answer wrong because they failed to select their newly inserted coordinate system and instead use the default values. Ugh. Even if you don't mess up a drawing and need to move the origin, the SOLIDWORKS folks often have you do this as part of the exam, as it's an important skill. None of the drawings you'll see in the CSWA are terribly complicated. Some just look that way. Try to relax and look at the drawing as a puzzle. That is, what primitive shape can I start with? What are my next steps? Here again, please take the time to think about the model's geometry before you start modeling the part. Here's another advanced part from a prior CSWA exam. This is the unmodified part. You could draw 1/4 of the top profile while using dynamic mirror and then revolve this around the center axis. Use the shell feature, draw the top hole in the rim, and then use a circular pattern to complete the drawing. Hey, sounds pretty easy, huh? Here's the modified part. Yes, I realize it looks nasty, but it's really not. All you have to do is model one of the slots. The rest can be done via the circular pattern feature. Note also dimensions have changed, but if you use global variables, this is a snap. And don't miss the holes in the rim. These went from 5 to 4, but is easily accomplished by just modifying the circular pattern you used to create them. In this unit, I covered how to specify document properties, interpret engineering terminology, and build an advanced part from detailed dimensions illustration using the following tools: 2 and 3D sketch tools, extruded boss base and cut, fillet mirror, revolve boss base, linear and circular pattern, chamfer, and revolve cut. How to locate the center of mass relative to a part origin, how to create a coordinate system location, and how to locate the center of mass relative to a created coordinate system. There's a SOLIDWORKS demo for this unit that covers creating a new coordinate system as well as some example advanced parts. Don't hesitate to email me questions or concerns, and as always, thanks for watching.